Hello. Today I'm going to show you how to prepare a sample to run in our nuclear magnetic resonance spectrometers. The equipment you'll need is shown here. This includes a cleaned and dried NMR tube and cap, a new Pasteur pipette and clean bulb, a clean and dry sample vial, and, if further filtration is required, a second Pasteur pipette and a small amount of paper towel. I'm going to start by adding a small amount of sample to the sample vial, approximately 5 to 10 milligrams, but if more is available it can be used. If the sample to be analysed is carbon-13, a larger quantity of pure dry product is required. A minimum amount of 30 milligrams is required as the default experiment to give a good signal-to-noise ratio. To this sample, I'm going to add approximately 1 milliliter of solvent and mix it thoroughly. I'm using deuterated chloroform as my solvent, as the deuterium offsets the effect of natural drift in the magnetic field of the NMR. The solvent I'm using also contains TMS, which is used to define the 0 part per million reference standard. TMS is useful for most NMR samples, but less so with silicone-containing compounds, as it will interfere with the signal. The sample is mixed thoroughly until all of the compound is dissolved. I'm also going to run an analysis of a less soluble compound. The same procedure is followed. A small amount of sample, approximately 5 to 10 milligrams, is added to the sample vial. Approximately 1 milliliter of solvent is added, using a clean Pasteur pipette. And the sample is mixed thoroughly. Although in this case you can see the sample does not completely dissolve in the solvent. To solve this, further solvent can be added, a few more drops of deuterated chloroform, If this too is unsuccessful, a small amount of DMSO, dimethyl sulfoxide, can be added. The sample is then mixed again, and you can see the impurities have dissolved this time, although there are still some particulates left in the solution. To remove these, filtration is employed. A small amount of paper towel is rolled up into a loose ball, and this is pushed into the top of a clean Pasteur pipette. This is then pushed into position at the bottom of the Pasteur pipette. This prevents liquid flowing past the filter. The pipette is then inserted carefully into the NMR tube. The sample is then pipetted into the top of the filtration pipette and allowed to filter through into the NMR tube. If the paper towel is too big, the liquid will not filter through quickly enough and will also be absorbed onto the paper towel. So it is important the paper towel is only a small amount. The NMR tube is made with a uniform thickness, which gives better resolution when using higher field magnets. Our spectrometer requires a specific type of tube. The top of this tube should be even and smooth. If damaged, there is increased likelihood of the glass breaking in the machine, and the tube should be taken to the glass blower to be fixed. The cap is then carefully placed on the tube, preventing damage. The liquid from the soluble sample is then added to the other clean NMR tube. The vial should be filled to around 4 centimeters. Any less than the data will be inaccurate. Larger amounts would be wasteful and make shimming worse. The tubes are delicate and must be handled with care. The liquid should come up to about 4 centimeters. Thank you.